We also have a divergence criteria for subsequences. Now, previously, for subsequence convergence theorem, the limit or the subsequence converges to the same limit of our given sequence. Okay? But this time, we can also identify immediately whether our subsequence is divergent or not following this statement. If a sequence x sub n of real numbers has two convergent subsequence x prime, which is the sequence of x sub n sub k, and x double prime, which is equal to the sequence x sub r sub k, but limits are not equal, then automatically x is, or the sequence x is divergent. Take note, for the subsequence convergence theorem, no matter how many subsequences can be drawn out from a sequence, all of those subsequences converges to the same limit of the sequence. In short, if there are more than one subsequences, they should have the same and equal limit. In this case, of course, if they are not equal based on this divergence criteria, then automatically x is divergent. Let's illustrate this using an example. Okay, let's say our sequence x, our x sub n, let us have here the sequence -1 raised to the power of n. Okay, using the natural numbers, you will have here when n is 1, -1. Is all, when n is 2 is positive 1. When n is 3 is -1. When n is 4 is positive 1. -1, positive 1, so on and so forth. This is an alternating sequence here now of -1 and 1s. Okay, now we can actually draw here two different subsequences. Let's say x prime, which is x sub n sub k, is denoted as, let's say, -1 raised to the power of 2n. Okay, so its elements of the sequence or terms you will have here when n is 1, so that's positive 2, so that's positive. When n is 2, it's 4, so you have here 6, and then 8, so on and so forth. So we'll have here all ones. Okay, so considering all of this, we can now draw that the limit of this sequence, okay, the limit of that, since it doesn't have, it's a constant sequence, so its limit is just equal to 1 itself. Okay, so that is the first limit, or the limit of the first subsequence. If we're going to have another subsequence here, let's say your x sub r sub k is denoted as -1, and then you will have here 2n, or let's just say n plus 1. 2n, so sorry, let's have here 2n minus 1. Okay, so its terms or elements, so when n is 1, 2 times 1 is 2, minus 1, that's 1, so -1. When n is 2, 4 minus 1 is a 3. I'm talking about the exponent, so it's negative as well. Negative, negative, and so on and so forth. So again, it's a constant, so you'll have here -1, 2, raised to the power of 2n minus 1. Its limit is -1. Now, both of these two are considered to be subsequence of x. Okay, they are subsequence of x. But as you can see, their limits, okay, their limits are not the same. So with this divergence criteria right now, since the limits are not equal, we can now further say that x, being a sequence x sub n, is divergent because of this divergence criteria. So in the future identification or illustration of examples, if you're asked about whether the sequence is divergent or convergent given two convergent sequences, simply identify the limits of those two subsequences, and if they are not equal, then automatically the sequence is divergent. Thank you very much for watching.